Hi, welcome back. Network issues, we'll get back into that. So, apologize for not writing this out in real time. I'll just say network issues. We'll leave it at that. Anyway, so in your notebooks, my class, you're going to put this information so that you've got it easily at hand so you can look back at it. So we're talking about displaying relationships and scatterplots. Important idea number one, types of variables. And again, this is stuff that I know that I teach in my algebra class, but it's one of those things where it's good to review and make sure that we're all using the same language, we're using the same setup. So there's explanatory and there's response variables. Explanatory is the one that we use to predict things. So, in this case, I would have given you 7 rubber bands. You're going to use all of that data to predict how far we can throw Barbie. Or if we were going 15 meters, how, that'd be 1,500 centimeters. How many rubber bands would you need to make sure that she was safe? And then response variable. And then, so then that's going to be the outcome, that response to the response or explanatory variable. And I know it's kind of a circular definition. You can feel free to complain to your English teacher if you want. Now for number 2 and 3. Number 2 is kind of the graph in terms of how we set it up. Again, this is not meant to be something where I'm insulting your intelligence. Excuse me for a second. This is just one, I'm going to make sure that everybody's on the same page. So you've got your explanatory variable down here on the bottom on the x-axis, or independent variable, sometimes you may refer to it like that, and up the top and along the side is your response variable on the y-axis. Now, in terms of how you describe these, somehow I lost, there's my, consistency mysteries. How do you describe this? Remember, we've got direction. So are you talking about, is it going up, is it increasing, decreasing, or is there none? So if it's just all over the place, that would be there's no direction to it, or it's just flat. Are there any unusual features? And by that, mostly it's outliers or a section that just doesn't seem to fit. Is there a form? At this point, all we're really going to really care about is linear and nonlinear. And then last but not least, there is strength. Okay, how strong is it? Is it moderately strong, very strong, extremely linear, that type of thing? So down here in Check Your Understanding, we're going to talk about sugar and candy. I told you this class had a lot of food in it. Just wait until second semester, as I've said before. But hit pause here, run through these, and then come on back. So identify explanatory response. So is there a relationship between the amount of sugar and the number of calories in movie theater candy? Now, obviously, yeah, probably. But, it's good to kind of know exactly how the things work, because obviously other things can contribute to calories. So here's samples from 12 types of candies, blah, 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 blah. Find your favorite. Skittles are good. Sour Patch Kids are good. Twizzlers, especially if it's the pull and peels. Hashtag end of your gift. So, in this case, explanatory sugar is the explanatory variable. Why? Because we are kind of hypothesizing as the amount of sugar goes up, what happens to the number of calories? And calories are the response. Explain your reasoning. What happens if you add sugar? If you add sugar, calories go up. If we make the calories go up, is it because it's sugar? No, there's other things. There's fat. It's the most likely one. Protein. If you add sugar, the calories increase. Okay? Make a scatterplot to display the relationship between the amount of sugar and the number of calories in movie theater candy. Okay? When you do that, you're going to get something that looks like this. Where'd it go? Here's my pause. I don't have a pause. All right, I'll do this quick. I was going to throw things into Statlet really quick. And you end up kind of getting a cluster here, cluster up here, one way over here, and then some down here. Okay? So again, sugar would be down here. What are we measuring sugar in? Grams. We'd have calories up the side. So, think about what the description. Direction. Is it increasing or is it going, is it positive or negative? Is it going up or is it going down? This, you would actually say, is a fairly strong linear pattern. Now, is it perfect? No. But it is generally, the way that I kind of describe it is if you can put, if it's staying kind of within two semi-parallel lines, or even if it's slightly skew, like in this case, not skew, I'm sorry. But I mean, they're definitely in a pattern, and they're kind of going out that way, then you can kind of say fairly. If it's relatively parallel, then it kind of depends on how close they are. So here, the scatter plot, make sure we're on the screen. So it shows you positive. Fairly strong linear relationship, or linear pattern. Where's your possible outlier? The possible outlier, the only one that's really kind of standing out would be this one out over here. And that turns out to be, if you look at it, this is about 80. And so that actually turns out to be your peanut M&Ms, which is right here. And that's at 79,790. And the reason why is that one the outlier, because think, that's the one that, as I'm looking at it this way, is kind of forcing me out. If it's otherwise, everything kind of stands right there. So that would be why we'd kind of consider it the outlier. So with that, we're done with Scatterplots. See you tomorrow.